Okay, so this is the 2025 Higher Level Maths Leaving Cert Paper 1, Question 3a. So the function f of x is defined for x is real by f of x is equal to 3x to the power 5 minus 4 to the power 28. Find an expression for f prime of x. You do not need to simplify your answer. Okay, so if we don't need to simplify the answer, we can just use the chain rule, take the 28, bring it down. Write down what's in the bracket, 3x to the power of 5 minus 4, and then reduce the power by 1 to 27. Now we need to now differentiate what's inside the bracket. So if you differentiate what's inside the bracket, you have 3x to the power of 5, so bring the 5 down, multiply by 3, so that's 15, and then it's x, reduce the power by 1, so that's the power of 4. You could go another step if you wanted to. It doesn't say to do it, but you could multiply the 15 by the 28, and that'll give you 420. You've got the x to the power of 4, and then you've got 3x to the power of 5 minus 4 to the power of 27. But they say don't simplify necessarily, so this is your answer here. Okay, so let's look at part B. The function g of x is defined for x is real, x is not equal to 3.5, by g of x equal to 3 over 2x minus 7. By finding g prime x, show that this function has no local maximum or minimum points. Okay, so we have g of x equal to 3 over 2x minus 7. So we want to differentiate that. Now you can do this two ways. You can use the quotient rule if you want, but I'm going to do it using the chain rule. So I'm going to just rewrite the original function as 3 times 2x minus 7 to the power of minus 1. When we differentiate that, then we get g prime of x is equal to, bring the minus 1 down, multiply it by the 3, so that's minus 3. Write out what's in the bracket, 2x minus 7. Reduce the power by 1, so that goes to minus 2. And then differentiate what's inside the bracket, so you just get 2. Differentiate 2x, you get 2. Differentiate the minus 7, you get 0. So just to rewrite that, then you've got 2 times minus 3, which is minus 6 on the top. And then the 2x minus 7 to the power of minus 2 just becomes 2x minus 7 squared. Now it says that by finding this, show that the function has no local maximum or local minimum. So you can say something like the numerator of a fraction has to be 0 for the fraction to be 0. And you can see here that minus 6 is not equal to 0. Therefore, g of x has no local maximum or local minimum. So in other words, the normal way you would find the local maximum or the local minimum is to do the first differential here and then let it equal to 0. But this fraction here can never be equal to 0 because the numerator is not 0. Okay, let's look at part C. K is real, is a constant, and the integral from 0 to k of e to the power of 5x dx is equal to 9. Use this to find the value of k. Write your answer in the form k is equal to log a over b, where a and b are natural numbers. Okay, so let's write down our integral first. It's a definite integral from 0 to k of e to the power of 5x dx is equal to 9. So what we've got to do is integrate e to the power of 5x. Now, if you integrate e to the power of x, you get e to the power of x. So if we integrate e to the power of 5x, we get e to the power of 5x. However, if you check this, if you differentiate e to the power of 5x, if you differentiate e to the power of 5x, you'll get e to the power of 5x, but then you've got to differentiate the 5x. So you'll get an extra 5 there. There isn't a 5 here. So that means we've got to put in a 1/5 here to cancel out this 5 here, if you like. So in other words, if we had a 1/5 here, we would get 1/5 e to the power of 5x times 5. These two 5's would cancel and we would end up with an e to the power of 5x. So this is our integral here. Our limits are 0 to k. This is equal to 9. So all we've got to do is do this and solve for k. So let's work our way through this. We've got to substitute in k first. So we should get 1/5 e to the power of 5k minus 1/5 e to the power of 5 times 0, and that's equal to 9. So here we've got 1/5 e to the power of 5k. Here we will just get e to the power of 0, which is 1. 1 times 1/5 is just 1/5, and that's equal to 9. Okay, so let's just bring this 1/5 over to the other side, add 1/5 to both sides. So we get 1/5 e to the power of 5k is equal to 9 and 1/5. 9 and 1/5, I'll just write that as an improper fraction. So 5 9s 45 plus 1 is 46 over 5. So I'm just dealing with these two parts now. So the next thing I'm going to do is multiply both sides, this side and this side here, by 5. If I multiply this side by 5, it'll get rid of this fraction. So I've got e to the power of 5k. Multiply this side by 5, I'll just get 46. Okay, we're almost there. I'm just going to change this from index form to log form. I'm going to use natural log. So there'll be an e here if you like. So it's the log of 46 is equal to 5k. E to the power of 5k will give me 46. So next line then is just, we've got to write our answer in the form log of something over something. So I want to get k on its own, so I'm going to divide both sides by 5. So it's the log of 46 over 5 is equal to k. So this is my answer here. We were just asked to write k in the form log a over b, where a and b are natural numbers. And you can see 46 and 5 are both natural numbers. Okay, so that's it for this question.